All right, so in this video, we're going to be solving systems of linear equations by elimination. So in 4.1, we talked about how to solve it graphically by doing it on graph paper. I also showed you how to do it with your calculator, which is extremely useful, and I hope that you definitely have memorized that by now. And in 4.2, we solved it algebraically using a method called substitution. Now, when I was growing up and I was literally your age, that was the only method that I was taught was substitution. This next method, I actually learned this method when I became a college student. And when I found this method, this actually became my favorite method for solving these systems of equations. It just did. I found it easier. Now, with that said, does that mean Mr. Lewis expects you to find this easier? No, not necessarily. I want you to be able to do all three, well, technically four methods if we include the calculator, all four methods of solving a system of equations with graphs. I want you to be able to use a calculator. I want you to be able to graph it manually. I want you to be able to solve it by substitution. And I want you to be able to solve it by elimination. All right, now, with that being said, let's talk about what's happening here. I'm going to give you the basic rules. It's kind of like substitution. These are the overarching rules and steps, but there's a lot of little mini things that we've got to do inside of it. But just kind of like last time, we're going to go through these. So, one, when we get a system of equations, we need to multiply, if necessary, one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficients. I'll explain that in just a few minutes. Two, add the equations if coefficients are opposite. Or the next piece, subtract equations if the coefficients are the same. So this right here, you have to make a decision. If they are opposite coefficients, you add. If they are the same coefficients, you subtract. 3, solve the new equation for the remaining variable. 4, substitute value from step 3 into one of the original equations and solve. All right, so I am actually going to have a little bit of extra paper on this. So I will grab some paper here. So to be brutally honest, on these problems, I don't personally think you have a lot of room here to write on and to be able to keep track of all the little moving parts here. So I'm actually going to write this on another page here. I would suggest you probably do the same, especially when you go to do this out of the book. Do not try to solve these problems in your head, and do not try to solve these problems by writing on a small sheet of paper. You need plenty of room to be able to write and to be able to breathe and to keep your thoughts organized. Now, with that said, our job is to solve this system of equations. We are trying to find what is the ordered pair that these two lines cross at. So, with that said, let's look at how we do this. Step 1 says multiply, if necessary, one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficients. So let's look at the terms. I have an x here, and I have an x here. Notice that this x is a 1x, and this x is a 3x. They are not the same, and they are not opposite. Now let's look at our y's. This y is a plus 1y. It is a positive 1y, and this one is a negative 1y. That right there shows us that this y and this y from these two different equations are what we call opposite coefficients. And because of that, it leads us to step 2. Step 2 says we add the equations if the coefficients are opposite, or we can subtract equations if the coefficients are the same. And since in this particular one we looked at, they're opposite, we are actually going to add them. And the way we do that is literally to write it like this. X plus y is equal to 7, and then directly under it, 3x minus y is equal to 1. And we are going to treat this just like we would an old-time math problem, and we're going to put a plus symbol on the outside and our line under it, just like we would if we were adding numbers, because that's what we're doing. We are adding numbers. So let's go through it. X plus 3x is equal to 4x. Positive 1y plus a negative y equals 0. 7 plus 1 equals 8. And we notice that I brought down my equal sign. So 4x plus 0 is 4x is equal to 8. And then we have this next part. We get a new equation. All right, so what we just did is we added our equations, and we have 4x is equal to 8, which brings us to step 3, solve this new equation that we have and for the remaining variable. So basically in this case, all we have to do is divide by 4. And we get that x is equal to 2. So we just found that our x value for our ordered pair happens to be 2. So what do we do now? Step 4 says substitute value from this right here back into one of the originals. So I'm going to use this first one right here. X plus y equals 7. So I'm going to plug 2 in the place of x. So 2 plus y is equal to 7. Subtract 2 on both sides, and so y is equal to 5. So if we have done this correctly, our answer should be, for our solution to where these lines would cross, would be at ordered pair 2, 5. Now, what we've got to do is verify that. How do we verify it? We take this ordered pair and we put it back into the second equation. So I'm going to go 3 times my x, in this case it's 2, minus 5, which was what we just said to be y, equals 1. 3 times 1 is 6, minus 5 equals 1. Is this a true statement? Does 6 take away 5 equal 1? It does. So our answer indeed is 2, 5. So this is the solution to this system of equations. All right, so number 2. I'm going to do the same thing. I'm going to write it down. Negative 2x minus 5y is equal to negative 8. And then the other equation is negative 2x plus y is equal to 16. Now, step 1 tells me to look, first off, I need to look at each terms and determine if they have the same or opposite coefficients. Well, let's look right off the bat. I have a negative 2x here and a negative 2x here. Right now, these two are the exact same coefficient. All right, so I don't have to do anything else to this. I don't have to multiply because they are the same coefficient. Now, that brings me to step 2. It says subtract equations if the coefficients are the same. So I'm going to set it up. 2x minus 5y equals negative 8. And the other equation was negative 2x plus y equals 16. Now, notice what I'm doing here. I am putting a subtraction symbol on the outside. Know how I did that with a plus symbol? It's imperative that I remember that this is a minus on the outside because I'm subtracting this. This right here is not the subtraction symbol that we're using. I'm not going to go negative 2x minus 2. I'm doing negative 2x minus a negative 2x because they are the same coefficient. And when I do that, a negative 2x minus a negative 2x gives me 0. And then I have a negative 5y minus a 1y, because there's a hidden 1 there, gives me a negative 6y. And this is equal to, now we go negative 8 minus 16 gives me negative 24. We can simplify this to say negative 6y is equal to negative 24. So I've added my equations, and now it says in step 3, we need to solve the new equation for the remaining variable. So all I have to do now is take this and divide by negative 6 to solve for y. When I do, I get that y is equal to a positive 4. Now, Oops, I'm sorry, I went off the page. All right, so y is equal to a positive 4. Pause the video if you need to kind of go back and look at that again. I apologize. All right, now that I know what y is, I am going to put that up here so I don't forget it. And my job is to find out what x is. So I'm going to use this equation, and I'm going to plug y, which in this case is 4, into that equation. So negative 2x minus 5 times 4 is equal to negative 8. And my job is to solve for x. So let's do that. We're going to multiply here using the distributive property, and we'll get negative 2x minus 20 is equal to negative 8. I'm going to add 20 to both sides to cancel this out because we're using SADMEP, and I get negative 2x is equal to a positive 12. Now I'm going to divide by negative 2 because we got to get rid of that multiplication through division, and we're dividing by negative 2 on both sides, and that cancels out to give me x is equal to a negative 6. So I found my x value for my ordered pair. So if I've done my math right, the solution to these two linear lines when they cross on a Cartesian plane is going to be at negative 6, 4. This is where your x will meet. So we need to verify, is this correct? So let's find out. What do? We plug it back into our original equation. We'll use the second one this time. Negative 2 times negative 6 plus a positive 4 equals 16. Negative 2 times negative 6 is 12 plus 4 is equal to 16. Is this a true statement? Yes, 12 plus 4 does equal 16. So our answer is correct. All right, number 3. Now, we'll do the same thing. We'll write it off to the side so I know what it is. 8x minus 9y is equal to 7. 2x minus 3y is equal to a negative 5. And my job is to find what the ordered pair is. So with that being said, let's compare our coefficients for each of the variables. My x's, this has an 8, this has a 2. My y's, this has a minus 9, this has a minus 3. Stop. Right now, you should notice that nothing is the same and nothing is the opposite. So step 1 tells me I need to multiply one of these or both of these by some constant to make the variables at least equal or opposite. So the question you need to ask yourself is, which one do you want to use? Do I want to multiply and make my x's to be the same number, or do I want to multiply by something and make my y's be the same number? Here's the simple truth. It does not matter. You pick what you want to pick. You pick what looks like it to be easiest for you. Quite frankly, I can see about 4 different methods that from this one step alone that I can do and still get the same answer. So there's about 4 different ways I can solve this problem right now. All I have to do is choose. So what I'm actually going to choose is I want to get my x's to be the same this time. So what I'm going to do is I have to ask myself, what number can I multiply 2 by to get 8? Well, I can multiply it by 4. And so when I do that, I'm going to multiply this entire equation by 4. Okay, so I'm going to write this down and we're going to do it all together. So I write my first equation. And now I want to rearrange this. I know if I go 4 times 2x, I get 8x. And 4 times a minus 3y gives me a negative 12y. And 4 times negative 5 gives me a negative 20. So I have multiplied this equation by a constant to get to where both of these have the exact same coefficient. And that brings me to step 2 now. Since they are the exact same coefficient, I am going to subtract. 8x minus 8x equals 0. Negative 9y minus a negative 12 is going to give me a positive 3y. 7 minus a negative 20 gives me a positive 27. Okay, sorry, I went off paper again. Gives me a positive 27. So I've just did step 2. Now, step 3, let's solve for y. Basically, all I got to do is divide by 3 on both sides. So y is equal to 9. So I know my 9. Now, since I know this, I plug y back into one of my original equations. So let's do it. 8x minus 9 times 9 equals 7. Let's keep simplifying. 8x minus 81 is equal to 7. Keep simplifying. 8x, and we're going to add 81 to both sides, gives me 88. And then we're going to divide by 8 on both sides, and I get that x is equal to 11. All right, now we need to verify that we've got it right. So we need to plug this information back into the second equation, not the one we created, but the original. So we're going to go 2 times 11 minus 3y equals negative 5. So not 3y, but 9, sorry. 3 times 9. 2 times 11 is 22 minus a 27 is equal to negative 5. 22 minus 27 is negative 5, and that indeed does check out. So my correct answer is 11/9. All right, this is where my line will cross. So let's look at number 4 now. Number 4, we have this. We have negative 5x plus 3y equals negative 6. And then we have 9x minus 4y equals 1. My job is to find what the ordered pair is when we graph these things and see where they cross on a Cartesian plane. So, right off the bat, you should notice that none of the coefficients either match. I have a negative 5 here and a 9, so they don't match. I have a 3 here and a negative 4 here, so they don't match. So that means that step 1, I have to multiply both of these equations by some number to get them to have the exact same coefficient or opposite coefficients. Well, I can do it a couple of different ways, but the easiest one that I personally see is multiplying so that this becomes a 12 and this becomes a 12. So I'm going to multiply this whole first equation by 4, and I'm going to multiply this whole second equation by 3. So let's do that. 4 times negative 5 gives me a negative 20x. 4 times a positive 3y gives me a plus 12y. 4 times a negative 6 gives me a negative 24. Now let's do the second equation. 3 times 9x gives me 27x. 3 times minus 4 gives me minus 12y. 3 times 1 gives me 3. Now, we're going to, since both of these are opposite coefficients, we can actually add these equations. Negative 20x plus 27x gives me a positive 7x. Positive 12y plus a negative 12y cancels out and gives me nothing. And then I have a negative 24 plus 3 gives me a negative 21. Now I can go on to step 3 and solve this equation by dividing by 7 on both sides, and I get that x is equal to negative 3. So that's the first part of my ordered pair. Now that I know that, I can plug this negative 3 back into one of the original equations. So I'm going to use this one. Negative 5 times negative 3 plus 3y equals negative 6. Negative 5 times negative 3 gives me a positive 15 plus 3y equals negative 6. We're going to do SADMAP now because we've simplified this expression on this part of the equation, and we're going to subtract 15 from both sides. And I get 3y is equal to negative 21. Now I'm going to divide by 3 on both sides to continue my SADMAP process, and I get that y is equal to negative 7. So if I have done this right, my ordered pair for the solution of these two equations when they are graphed and where they cross at should be at negative 3 and negative 7. So we have to verify it. How do we do that? We take this and plug it into the second equation. So we're going to go 9 times negative 3 minus 4 times negative 7 equals 1. 9 times negative 3 is going to give me a negative 27. A negative 4, notice what I said, this is a minus 4. So a minus 4 times a minus 7 is going to give me a plus 28 equals 1. Well, negative 27 plus 28 is indeed 1, so this does check out. Whew, that is a lot of stuff. Now, I said before, This is actually my favorite method of doing things. I took my time in doing this so that you can see every step, and I've taught with every step. But after a while, the more you practice it, the faster you will get. So let's look at number 5, and I'm going to leave it with you. We're going to help you kind of create your equations. So it says a school has a total of 850 students. There are 60 more female students than there are male students. So stop right there. We know that we're going to label things. We know M is going to be for males, and we'll use F for females. And since we don't know how many we have of that, we can just say however many males plus however many females is equal to 850, because there's a total of 850 students. Now let's read this next piece. There are 60 more females than there are males. So what does that mean? It means that males plus 60 more of them will be our females, okay? And that's how that works. So males plus females is 850, and males plus 60 more, according to this, is equal to our females. So now that we know that, you can find out how many males and females are in this high school. All right, that's the end of this video. Know it was a little bit of a long one, and it's a lot of information, but like I said, this is a very useful skill that I really enjoy, I personally enjoy, and if you know how to find me. So I'll see you in the next video. Bye-bye.